everybody, it's Elise and welcome to a hands-on science brought to you direct from the William Hall Library. So we posted our list of experiment ingredients earlier this week. They consisted of a handkerchief or a coffee filter or a piece of tissue paper, some string, and some kind of little doll, like a dollhouse doll or a Lego figurine. Can you guess what we're going to make today? If you said parachutes, you were right on the money. We are absolutely making parachutes today. So parachutes, if you've never seen one before, are these big fabric or nylon, sort of U-looking things that skydivers, people who jump out of airplanes for fun or sometimes for their job, use to slow their falling back down to earth. So the reason why people use parachutes is because if you've ever fallen maybe off of a chair or off of a couch, you might have noticed that you hit the ground pretty hard and it's super not fun. In order for skydivers to land safely when they jump out of really high things off the ground like planes, they use a parachute in order to defy gravity. So gravity is a force that acts on all of us to make it so that we don't just float away. If you jump and come back down to earth, that's gravity. But parachutes allow you to slow yourself down when you're jumping or falling off of something. And we're going to test out parachutes, what kind of materials work better today in our experiment. So first, we're just going to observe the phenomenon known as air resistance. Air resistance is what parachutes take advantage of and skydivers take advantage of when they're jumping out of planes. So if you were to drop two different objects, they would fall at different rates. From our first experiment, I have like a little doll from a dollhouse. This is little sister from our Storytime dollhouse. Hello, she brought her teddy bear as well. They're both part of this. And I have just a plain old piece of tissue. So how many of you guys out there think that if I drop them both at the same time, both from the same height, that they're gonna land on the ground at exactly the same time? Okay. Okay. How many of you think if I drop them from exactly the same height at exactly the same time, little sister is going to land on the ground first? Okay. Okay. Now, how many of you guys think that if I drop them from exactly the same height at exactly the same time, the tissue is going to land on the ground first? All right, so the votes are in. If you thought that little sister would land on the ground first, you were probably correct because of air resistance. So little sister is heavier than this piece of tissue, and she's also smaller. So even though the air is invisible, it's made of all different gas molecules. And to land on the ground, they will both be pushing the gas molecules out of the way. Because little sister is heavier and smaller, she's going to encounter fewer gas molecules and she'll be able to get through them faster than the tissue, which is lighter and wider. It has more what we call surface area in the sciences. So let's try our experiment. Our first experiment, hold up our doll and our tissue. If you have these, you can play along with me. I'll count us down and let's make sure this is nice and flat, just like a pizza. 1, 2, 3. The tissue just landed, and you might have heard little sister land when she plopped on the floor. We'll do it one more time just to test our results. And so same height, same time. Get ready with me if you can. 1, 2, 3. They both actually landed in the cupboard, but little sister fell faster than the tissue paper. So we have proved that something that is wide and light can encounter more air molecules and slow its rate of descent. That's the speed at which you fall and land on the ground when you jump from something high. Now, of course, most of us don't have planes or parachutes at home or parents who will let us jump out of a plane necessarily, at least not today. But what we can do is we can replicate this experiment using things that we do have. So if you guys have your little dolls and or your little Lego figures, I happen to have, let's see, a little T-Rex who volunteered to help me with this experiment. So I'm going to tie the T-Rex to the tissue and see if that slows him down. So I don't have a stopwatch with me. If you have a stopwatch or a stopwatch on your phone, you can actually time this. I'm just going to kind of time it by ear. for today. But if you guys want to get extra special scientific at home, I absolutely encourage you to do so. If you're just joining us, this is Hands-on Science from the Cranston Public Library. My name is Elise, and today we are learning about air resistance through parachutes. So we take our little T-Rex and we drop him, and he dropped in about 1.5 seconds before he landed on the ground by my count. So let's see if we can slow him down by making him a parachute. So I'm going to use my tissue paper and make him a parachute. Some of the other things we asked you guys to scrounge up from around the house was some string or some yarn. And I have a pair of scissors to cut it. So I'm just going to hold the string in my hand and then go around my elbow once. Yeah, that'll be long enough. Maybe twice. Yeah. Just want a long piece of string. And cut it. There we go. So I've got my long piece of string that I'm actually going to cut into 4 different pieces of string. So to get my first 2 pieces, I'm going to hold the cut end just so they're even, like that. And then I'm going to cut the loop that they make. I'll show you again. Just hold the 2 open ends together, and then you'll have a little loop right there. And that's what you're going to want to cut. And then hold all 4 cut ends together, and you'll have a little loop at the bottom, and then cut that. If you are not super comfortable holding scissors, you can probably ask an adult or a big brother or sister to help you. And then if you're really good at tying knots, or you have a sister or a brother or someone in your house who's really good at tying knots, they might want to help you tie each of your strings around all 4 corners. Broke the tissue. So the problem with tissues is they're very fragile, and I am sometimes not careful, but that's okay. I still have it tied on. You're going to tie your string around all 4 corners of your tissue. There we go. This is the boring part. I should have like a parachuting song that I can sing to entertain you all while I do this. All right. That's my 3rd knot, almost done. Poke through. There we go, 3rd knot. And then my 4th knot right here. And we have T-Rex, a brave volunteer. If any of you think of a name for T-Rex, leave it in the comments below. And that's what I will refer to this little brown T-Rex as for the rest of the video. And we're going to tie him up. So he's got 4 little limbs. And I want to kind of make him a little bit like a human skydiver. So I'm going to take the 2 ends like this. I'm going to see if I can do this because his arms are tiny. It's the problem with T-Rex. They have tiny arms and a big head. They didn't have any Lego figures downstairs, so I found these T-Rexes to substitute instead. And you can honestly do this with like any kind of little figure. Something like a dollhouse figurine might be kind of heavy, but you can still do it. A Barbie doll might be really heavy, or an American Girl doll would be way too heavy to use with a tissue paper. But if you have something little, or even I saw people online doing this kind of experiment with a pipe cleaner person, like they just made a little person out of a pipe cleaner, which was so cool. So if you even have like any kinds of crafting supplies around your house, you can even just make a person if you're like not a doll or an action figure kind of kiddo. Or adults. Adults can do this too. All right. Alrighty. So our T-Rex is tied, our little skydiver. And so let's see. So it took him about 1.5 seconds to fall last time. So I'm going to get him up, and drop, and it took him about 1 second longer to fall. So our tissue paper was successful. Let's do that one more time. Well, he bumped into something on the way down. That was not a good second experiment, but that's okay. When you're a scientist, it's important to try things multiple times to make sure you're getting the same result almost every single time. But, you know, if he happens to veer into the cabinet, we'll count that as a fail. Yeah, it took him about a full second and a half to fall when he was attached to his parachute. And so you can try this experiment with all kinds of different things in your house. I have another little T-Rex. I have a little black T-Rex who's all tied up to a different handkerchief. So let's see if they fall at the same rate. This guy's strings are slightly longer. I wonder if that's going to change anything. So I'll lift my arms both up high as I can and wish them luck. Oh, let's see. It looks like black T-Rex fell slightly faster. I'm going to back up Give them both a sporting chance and try again. 1, 2, 3. Oh yeah, Black T-Rex fell slightly faster every time. I wonder if it's because of his longer strings compared to brown T-Rex. These are the exciting things that you can do when you are a scientist. You can try different variables to see if you get different results with your experiment. So I have a couple of other different things that I use to tie up a few more volunteer T-Rexes. This one's green. So let's see if the green guy, who I don't know if you can see, but he's got a coffee filter instead of a tissue. Let's see if he falls any faster or slower. 1, 2, 3. Oh, they both fell at about the same time. Let's do that one more time. You can hear them banging into the cupboard. That's okay. They're hardy guys. They can take it. 1, 2, 3. Oh yeah, they both fell at about the same rate. One more time. 1, 2, 3. Just about the same rate for the coffee filter and the tissue, but that makes sense because the coffee filter and the tissue are just about the same size. They're both very light and they're both very thin, but I do have one outlier. I thought, oh, wouldn't it be fun if I tied a dino to a big old plastic bag? Now the plastic bag looks a little bit more like a balloon. There's lots of room for the air to get in here. So let's see if that makes a difference. So we've got our brown dino and our gray dino, and they are just about ready to go. I'm just trying to keep the bag open to make sure that we can get some air in there. All right, and 1, 2, 3. Oh, the plastic bag dinosaur fell much more slowly. Let's try that again. We always want to try and replicate our results. 1, 2, 3. Yeah, the plastic bag dinosaur is winning in the slow descent race. 1, 2, 3. He's won 3 out of 3 times. So what I encourage you guys to do is look around your houses, look for some little dudes that you can use as your skydivers, look for different materials. You can use what I used, plastic bags, tissues, coffee filters, or you could use newspapers. You could try out with cloth if you've got handkerchiefs or pillowcases, and try from different heights. Like, is there a difference if you're dropping something off the back porch or off the front steps or off your bed or off the back of your couch? The possibilities are endless. If you want to be a really good field researcher, you could write down your times, how high you drop the object from. If you have like a kitchen scale, if your mom or dad has a kitchen scale to weigh out food, you could weigh out your little figurines and see if the heavier ones fall at different rates than the lighter ones, and if it matters what kind of thing they're attached to make their parachute. So I hope you guys had a really good time following along with Hands-On Science today. We will be back next Friday with another science lesson. Until then, have fun exploring in the world, and I hope you enjoyed it today. Take care and be well. Bye, guys.